So let's take a quick look. We'll go again. We'll just cut this thing off at 9:55. So stop me. Don't let me go beyond 9:55. All right. So we're going to review relations and function stuff real quick. Click those all the way closed. Determine the domain and range of the relation and tell whether the relation's a function. So how would I get the domain? Right. It's just the set of all the x coordinates. What if I have, so what is it going to be here? You tell me. Let's put them in order. What's it going to be? Okay, now don't do the 4 twice, do I? Just once. Good. Then 22, then 34, then 52. Gotcha. Okay, the range would just be set of all the y values, and I'm not repeating values, right? So just show me with your fingers, how many of my y values am I going to have? I agree, 3, right? There's 3 different y coordinates. We would just put those in order. And is it a function or not? Thumbs up or down? Thumbs definitely down. And what's the giveaway? Okay, what is it, the y values? The x values, right? Does it matter that I have repeated y values of 6? Makes no difference, right? That's not an issue. Because remember, this tells me, for example, if I look at these 2 points, the first and the third, here, I'll put arrows up here. If I'm looking at that value and that value, that's okay, right? Because this is just telling me for an input of 4, I get 1 output, 6. For an input of 34, I get 1 output, which happens to be 6. That's okay. Y values can be repeated. But the problem is right here. Right? I get the same input value twice. So the input value 4 has more than 1 output, and therefore it's not a function. Okay, give me thumbs. We all good on that? Perfect. All right. How about one like this where they give you a graph? Okay, first of all, think about this for a second. What's the domain of this function? X is greater than -3? Greater than or equal to, right? How come we have to include -3? Well, because -3, there is a point on this function with an x coordinate of -3. Agreed? Like if we look at this one point right here, it has coordinates -3, +2. So we have to do A. Okay? And remember how we get that? It's just the set of all the x coordinates contained on the entire function. And a good way to think about this is projecting the function onto the x-axis. If we cast shadows on the x-axis, they would start there and then go to the right forever. Okay? How about the domain? All reals, because of the arrows, right? This function is going to continue to widen out vertically as we go to the right. And so we would just get all reals. Okay. Is it a function? No. How come? Fails the vertical line test. Right. Okay, so if we graph a vertical line, we get multiple intersections. Fails the vertical line test. Okay, what about this? It says use the graph of the function shown to the right to find all values of x such that g of x equals 8. So they're giving us g of x equals 8, input or output? Is that an output or an input value they're giving us? Output, right? It's the value of the function. Functions are just fancy ways of saying y, right? So that's just a y value. How would I find the solutions here? What would I do? What do you think? What is 8? X or Y? Y. Okay, good. And then we're just going to find all those intersections, right? So the easiest way to do this would just be to say, okay, let's take the line y equals 8. G of x is a fancy name for y. If we graph that line, okay, what do we get there? Well, we get how many intersections? It looks like we get an intersection there, there, and there. And we know that the y-coordinates of each of those points are what? Yeah, 8, right? Because that's where that horizontal line intersects the blue function. So those are all 8. So what are the x-coordinates in order, going from left to right? Yeah, it looks like negative 1, 2, 3, 4, 5. What's next? Negative 1 and then positive 2. Okay, so there they are. Okay, give me thumbs. How we doing? That making sense? All right. Forensic scientists use the following function to find the height of a woman if they are given the height of her femur bone, F, in centimeters. So this is the function they use to predict height. Right here, they give it to us as, H of F. F is the input, that's the length of the centimeter, or the femur in centimeters. So how would we predict the height of a woman whose femur measures 57 centimeters? What would we do? Plug it in, right? That's just a value of F, isn't it? Right? So I'm just going to plug 57 in. And that's going to give me 2.59 times 57 plus 47.24. Okay, now you want to always look at this, the part of the question that tells you how do you input the question. So what are we going to input here? How are we going to put this in as a fraction? What are we doing? What's it tell us to do? As a decimal, right? Integer, well, it's probably not going to be an integer. It's going to be a decimal. And if we just plug this in, there's what we get. Now, what's probably the best way to do? You have access to, for this part of the test, you have access to Desmos Scientific all the way down. I think maybe at the end you get graphing. I can't remember. But for here you have the scientific. So what would I do to use that technology to get this correct? A couple options. I could just do that, right? Just type it in like that. Or remember, I could define the function and then type H of 57. Or what might be better if I'm using Desmos rather than using like H and F, and it might be easier just to use X's as my input. But you could do it even this way. You could even say H of F if you wanted. Just type it exactly like that, give it the input value, and it'll do the computation for you. Okay, 1 to 5, how are we doing? All right. So rewrite the given equation in slope-intercept form, and then we're asked to do some other stuff. Okay. How do we, explain to me real quickly, how do we take a linear equation and put it into slope-intercept form? What does that mean? Yeah, isolate y and simplify, right? That's it. We just isolate y on one side and simplify the other side. So let's just take this quick equation. This is pretty easy stuff. At this point, your algebra skills are going to take care of this without batting an eye. What do we do to isolate y there? So say it again. Add 35 and subtract 5x. So first step, good, would be to move these terms away from the left side. Okay, which is good. We get rid of those. So then we get 7y equals negative 5x plus 35. What's next? Divide by 7. Okay, what's that look like? Talk me through that step. If I divide by 7, what am I going to get? How do I divide? So on this side, I just get y. That's pretty easy, right? But how do I divide the right side by 7? Yeah, remember when I divide separate terms, I have to divide them individually. I don't want to write this with a common denominator. I want to split these terms up, right? So I'm just going to divide each one separately by 7. So what do I get for the first term? Good, because remember what we want to do is just write that as a coefficient times x. Okay, so we end up with negative 5/7 x plus 35 over 7 is, there you go. Okay. So there's our function. Now they want the slope and the y-intercept. All right, so, okay, so what's our slope here? Negative 5/7. What's our y-intercept? And we always graph lines the same way. We have to create 2 lines, connect and extend. Where do we start? Where's our first point where we anchor this thing? 5, good, on the y-axis. And then how do I get a second point? There you go, slope triangle. Remember the negative, if it's a negative slope, the negative always goes in the top. So we're going to rise by negative 5. That way we always run to the right. We get a second point right there. And then all we have to do is just, well, and the technology will do it for you. Just connect and extend. Okay? Give me thumbs on that. How are we doing? Good with all that? Okay. All right, we're almost done. How would we decide whether these lines are parallel, perpendicular, or neither? What's going to tell us? Slope, right? That's a slope issue, isn't it? If they're parallel, what would be true of the slopes? They'd be equal. Good. What if they're perpendicular? Opposite reciprocals, right? So remember what we have to do. We've got to switch the sign, flip the fraction, okay? So that's all we need are the slopes. How would I get the slopes? Well, what am I going to do, Samuel? Put it into slope-intercept, and I don't even care about the y-intercept, right? Really, all I need to, when I'm putting them into slope-intercept, I just need to get as far as y equals mx, and then I don't care about the rest. I just need the slope. So if we took this first line, for example, what are the steps to put that into slope-intercept form? Okay, good. We subtract 2x to the other side, so we get 3y equals negative 2x. Let's put the x term first. Plus 9, last step. Divide by 3. And we get for our first line, y equals negative 2/3 x plus, who cares? Right? All we care about is that, the slope. How about the second line? Okay, if we're doing the second line, what am I doing real quick? Subtract the 3x to the other side. Good. So we get negative 2y equals negative 3x minus 6. Last step, divide by negative 2. Good. And we get y equals, what's my slope going to be? Right, negative over negative is positive, so I get positive 3/2 x plus, who cares? And so now we can determine if they're parallel, perpendicular, or neither. Let's vote 1, 2, or 3. 1 for parallel, 2 for perpendicular, 3 for neither. What do we get? Perpendicular, great. Because the slopes are opposite reciprocals, we get the answer perpendicular. Okay, we're done, right? Okay, good. Finish it up tomorrow. Take advantage, get questions answered. You're finding intercepts and using them to sketch a graph. So how would we find the x-intercept? We've got a linear equation in standard form, right? I could put this in, to graph it, I could put it into slope-intercept form. That's always going to work. But I could, really all I need are 2 points, right? And so I could use the intercepts as those points. To find the x-intercept, what do I do? Yeah, right, we know the x-intercept occurs when y is equal to 0. And so really all we got to do is set y equal to 0, which just means I can cover up the y term, right? Because if I set y equal to 0, then that term just disappears, it goes to 0, and then I just solved that equation. So when does 4x equal 4? When x equals 1. Yep, good. So we get the point 1, 0. So right there is my x-intercept. To find the y-intercept, obviously, what are we going to do? Yeah, we set x equal to 0, which means y equals 2. Good. Yeah, y equals 2. So we get the point, right about there, I guess. And then we just connect and extend, and we're good. Okay, good. Write an equation for the vertical line passing through the point -3, 6. Well, what's true about a vertical line? It looks like that. What's going to be consistent in a vertical line? Every point's going to have the same x coordinate. Good. And so the easiest one to think about would be, well, the one that we know, right? So then what's the equation of the line going to be? There you go. And just as a quick, memory aid on this one, for vertical and horizontal lines, remember those are the oddball ones. Those are the ones that are simple but different than most of the lines we deal with. Just ask yourself, which axis does it cut through? Well, it cuts through the x-axis, so it's x equals, and then the x coordinate of any point. Okay. Good. For vertical lines, you don't really need to, it says give the answer in, whether they say slope-intercept form or standard form, it doesn't matter, right? There's only one way to write the equation of a vertical line or a horizontal line. And so the form is really irrelevant. Okay, how about one like this? We want to write the equation of a line passing through 2 points. What do we need to do here? So yeah, so we need the ingredients of a line are a point and a slope. Good. So we have 2 points. You take your pick of the points, but we need a slope. So what's the slope going to be? So give me like what minus what on the top? Okay, good. I've got to subtract the y coordinates, and that's good. So we're going to do -11 minus -9. That's fine. If we're going to do the coordinates in the second point minus the first point, that's totally fine. We just have to be consistent with the x's. So what would we get on the bottom then? -6 minus -3. And what's that give us? On the top, we get -11 plus 9 is -2. -6 plus 3 is -3. So what's our slope? 2/3. So if that's our slope, take your pick of a point. How about that one? It's got slightly smaller coordinates. So what is point slope? Times the quantity x minus x1. Good, so then we would end up with y minus -9 equals 2/3 times the quantity x minus -3. Good. And then from there, it's always the same, right? We're just going to distribute the slope and then combine like terms. So we're going to get y plus 9. First of all, y plus 9 equals 2/3 times the quantity x plus 3. If I distribute the 2/3, what do I get? Plus 2. Good. Then we subtract 9 from both sides. And we get y equals 2/3 x, what, minus 7? Give me 1 to 5. I'm assuming everybody's pretty good on this stuff. Okay, good. Okay, what about one like this? It wants us to write the equation of a line through a given point perpendicular to a second line. So same exact problem as before, only we just are given the information in a different way. So we have a point. We need a slope. How am I going to come up with a slope? Opposite reciprocal of whatever that slope is, right? So how would I find the slope of that line? Divide by 4. Yeah, I'm going to put this into slope-intercept form, right? So if we divide by 4, that's going to give us y equals what? 1/4 x plus, who cares? Right? We don't even care about that part because what's the slope? 1/4. Okay. So that's the slope of the perpendicular line. That's our perpendicular symbol. So what's our slope going to be? There we go. So now we have a slope, we have a point. I'm just going to stop there. I mean, from there, we're just going to plug that into point slope and simplify, right? Okay, give me thumbs. We good? Okay. Okay, on to piecewise functions. So evaluating piecewise functions. We probably don't have to do all these, but let's pick a couple. What about f of -3? How am I going to evaluate this function at -3? What do I do? Say it again. Okay, so that goes into the top piece, right? If we color code these, like if we make this top piece blue, that one red, and this one green. This is a blue issue. How come? Yeah, -3 is less than or equal to 0, so it fits into that domain, right? So this is going to give us 3 minus 4 times -3. Well, what is that? 3 minus -12, so 15. Yeah, that makes sense, doesn't it? This is blue. Okay, what about f of 0? Blue again, isn't it? Right? Because, how come? Because of that, because of that equal sign. So again, this is a blue issue. If I plug 0 in, I just get 3, don't I? Right? Let's see, what about, do one more. What about f of 5? It's going to be red, isn't it? 5 is greater than 0 and less than 6. So that goes into the red piece. 2 times 5 is 10. Okay? That's all it is. You just got to figure out which domain does each input value fit into and then evaluate the function at that piece. Graphing a piecewise function. Okay, so if we have to graph this piecewise function, talk me through that. What am I going to do? Where's the boundary going to be between the pieces? -2. Okay, good. So then we're going to want to, at least in our mind, maybe on graph paper, we want to have a boundary line. Oops, wrong place. At -2, right there. Okay, So there's negative 2. Now what? Let's graph this top piece. This is going to be blue. So how do I graph that top piece? That's going to be domain to the left or the right of the boundary line? Left, okay. What do I do? Remember this stuff? It's a line. How do I graph a line? 2 points. Okay, where do I want the 2 points to be? Okay, on the boundary, good. We want to know where it ends, and then we want to pick a point to the left, right, in the domain. So this is where we just make a t-table. So in our, we've got the equation y equals 2x minus 1 in this region. And so if we make a quick t-table, what's first x value I should definitely pick? Negative 2. What is y when x is negative 2? Negative 5. 2 times negative 2 minus 1. Good. So negative 2, negative 5. What kind of endpoint am I putting there? Closed. Good. Because I've got an equal sign. So this domain includes negative 2. So we need a closed endpoint there. And then pick another one, like negative 3. I mean, this is arbitrary, up to you. If I pick negative 3, what do I get? Negative 7, yeah. So negative 3, negative 7. And we could have also used the slope there, couldn't we? We know if the slope is 2, I could have even made a slope triangle and just gone, instead of going up 2 and over 1, I could have reversed it, gone down 2 and back 1. That would have also worked. Either way, that's our left piece. Right piece, remind me real quick, so that's everything to the right of the boundary. For my t-table, what values would I want to pick here? What's one for sure I want to pick? I actually want to pick negative 2. Yeah, even though it's not in the domain, I want to know where this thing ends up. So if I evaluated this at negative 2, what would I get? 3. Okay, so it's not included in the domain, but it's still important. What would I do at negative 2, 3? Open endpoint. Okay, good. It's not included, but it's where the function ends. So open endpoint at negative 2, 3, and then what would the easiest one be to pick? 0. Yep, good. So 0, 1. And there we go. Okay, good. Give me thumbs. Good on the graphing part. Okay. How about the domain? Is it? Oh, yeah, it is. You're right. Yep, it is. Good. All reals because the open endpoint is covered up by the closed endpoint, and the function extends to the left and right forever from there, right? Good. So all reals. Another way of thinking about that, if we were projecting this onto the x-axis, every x value would be graphed, right? So what about the range? Okay, less than 3. Yeah, everybody agree? Okay, less than 3. All those y values from 3 down are included, all those y coordinates in that graph. Good. Okay. So now the other, we want to write a piecewise function based on the graph. Okay, so first of all, which of those has to be true, A or B? How come? You're right. Yeah, okay, good, because the piece that extends to the left from our boundary is the one that gets to keep the endpoint, which means it has to be that one, doesn't it? Okay, so we know it's A. So what is that left piece? What's the domain going to be for the left piece? X is less than or equal to -3, good. And it's just the line y equals x plus 0, right? You could, and it's easy to see that. If I just continue that line, it's got a slope of 1 and it goes through the origin, right? Everybody see that? I mean, we could use point slope if we wanted to, right? I mean, we could pick 2 points and calculate a slope and plug them in, but you can just by inspecting that, you can see that's just the line y equals x. Okay, how about the other piece? What's the domain? Greater than -3, good. And y equals 3, yeah, there you go. Okay, good. Okay, questions? Okay, how about this one? Graph the following. So what's the shape, show me with your arms, what's the shape of a graph like this going to look like? Yeah, it's going to be V, isn't it, right? It can be V-shaped, it's an absolute value graph. So what have we done to this absolute value graph? We just need to, we know the parent function is an absolute value function. What are the values of h and k? What are they? 2, -4. Not -2, right? +2, -4. And those are going to be the vertex, right? The easiest way to graph these is just to think of these in vertex form. That's where the vertex form has been moved to from the origin. So 2, -4, we're right here. And what's the value of a? One. Yeah, that's, a is just the coefficient of the whole thing, right? That's the constant that sits out in front, our vertical dilation factor. And so what's this thing? Have we stretched it vertically at all? No, we haven't, right? So then we know this is a regular shaped absolute value graph. So describe that to me. If I'm starting at the vertex and I go over 1 to the right, how far up should I go? 1. Go over 2, I should go up 2, and so on. So we know that's going to be the shape of this thing. If you wanted to, remember, you can always use a t-table, right? You know the vertex. Once I knew the value of h was 2, I could have just plugged that in and gotten the answer -4 for my vertex and then picked one other point. Like, for example, if I pick x equals 3, I would just get 1 minus 4 is -3, and then that's all I need, right? If I get the vertex and one other point, I can just reflect that over my axis of symmetry to get a second point, and we got it. Okay, take your pick. Either way would work. I would prefer not to use the t-table. I mean, it's just easier if you think about this as stretching or compressing the graph, the parent graph, based on A. But that's up to you. Okay, what about this one? You can just look at this right away and tell which one has to be the answer. 1, 2, 3, or 4. Which one? It's got to be 3. It's got to be this guy, right? Because all we've done, we haven't. So the pink is the graph that we're looking for, the transformed graph. We haven't moved this thing at all, so the vertex stays at the origin. The negative value of A flips it, and the 1/4 squishes it, and so the only one that could possibly work is that guy, right? Okay, give me 1 to 5 on that. I went fast. Okay. Okay, how about this one? So H and K. -4, 5, and we could, if we plug -4 in, we're just going to get 5, right? So either way, our vertex is at -4, +5. Let's do this by stretching. Okay, so normally we would go over right 1 and up 1, right? So now this time, what's the value of A? So we're going to go over 1 and up 1 times A. Up 1 times -4. So over 1 and up -4. What's that mean? Down 4. Yeah. So over 1, down 4. And there's our point. We've got our axis of symmetry through the middle, so we can just reflect that over. And there's our graph. Or if you want, would rather use a t-table, just pick a value like 1 to the right of that. So how about -3? If I plug -3 in, -3 plus 4 is 1. Absolute value of 1 is 1 times -4 is -4 plus 5 is 1. Right? Either way. Either way. Okay. Okay, this is probably, I would say, maybe the hardest of these kinds of questions. How am I going to get that graph? What do I need to do here? Say it again. Find the transformation, right? And a good place to start would just be with kind of what we know this thing has to look like, right? We've transformed an absolute value graph. And so we really just need to know the value of A, H, and K, and just remember where those show up in the graph, right? If we transform a parent function, H is the constant that's being subtracted from X inside the function, K is what's added outside, and A is the coefficient of the function, right? Okay, so 2 of those you know automatically. What are they? H and K. Because that's the vertex. So we know -2 and -3. That's good. So then we can plug -2 in for H, -3 in for K. What about A? How could we find A? A couple ways you could do this. What's one way you could find A? Okay, the slope, but I'd encourage you not to use, I mean, I know it's going to work for absolute value graphs, but it's not going to work for other graphs later, right? If this were a parabola or a square root function or something, there is no slope, so you can't do that. So I know it's going to work for now, but avoid that. How could you find the A by just inspecting this thing? Say it again? Compare it to the parent function. Yeah, good. So we can see here, look, they give us the coordinates of 2 points. What's this telling us? If we go over 1 to the right, the dilated height is, what, 3? Okay, so what is that then? 3 must equal A, the dilation factor, times the normal height that we would expect. Well, normally we would expect to go over 1 and up 1, right? So 3 equals A times 1. Solve for A. So A is 3. That's one way to do it. We had to stretch this thing by a factor of 3 to get that point up to there. Okay, give me 1 to 5 on that. How are we doing on that? Okay, that's a quick way to do it. The other way you could always do this is you could solve for A algebraically, because I know the values of H and K, right? So I have the equation Y, that's just Y. F of X is just Y, right? It's the output. Y equals A times the absolute value of X minus -2, so that's X plus 2. Plus 3, so that's just plus -3, so minus 3. I can see that this point right here gives me coordinates, so that's a solution of another point. That's a value of X and Y that work, right? I know that when X is -1, Y has to be 0. So I could plug -1, I could plug in for Y, and 0 I could plug in for X, and then I could just solve for A, right? So I end up with the equation -1 equals A times the absolute value of 0 plus 2. That's 2. So I get 2A minus 3. Just solve for A. Either way, I'm going to get the same thing, right? Well, what happened there? What did I do wrong? Oh, -1, not, yeah, you're right. Whoops. Whoops. Yeah. Let's do this. What'd I do again? Oh, yeah, they're backwards. There we go. Yeah. Thank you. Yep. Okay, so that y should have been 0. Just so our notes are right. I want to. When you guys look at this, it makes sense. Let's make that a 0, and let's make that a -1. Now we're better. So 0 equals, what do I have here? Minus -2. So that's going to become a 1, right? So that's a. 1 times a is a, minus 3. Either way, we get a equals 3, right? So when we plug 3 in, we plug -2 in, we plug -3, and we plug all those values in for a, h, and k, we just get that. Take your pick. First way's quicker. If that makes sense, it's quicker to just look at it that way. Look at it as a dilation. Figure out what the dilation had to be by comparing to the parent graph. Okay. We'll just do one of these. How would I know if this first one is a solution or not? Plug it in and see if it's true or false. Yeah. So 2 times -4 minus 5 times -5, is that greater than or equal to 10? I'm going to get -8 plus 25 is greater than or equal to 10, isn't it? Yeah. So that's true. So it works. That is a solution, right? Okay. We do the same for all of them. Okay, what if I want to graph an inequality? How am I going to do that? Because you don't have access to Desmos graphing. So how do I graph a linear inequality in 2 variables? What are the 2 parts of this I need to find? Right, so I need to find, like, what's it going to look like ultimately? Say it again? Okay, and I need to find a boundary line, right? And then one of those half planes is going to be shaded. Are we going to include the boundary line? We do, right? So it's a solid line because it's an equal sign also. So we could put this in slope-intercept form by isolating y. Does anybody see a quicker way to graph this boundary line? Intercepts would be a good choice, right? We could just solve for y. That's fine. But why are intercepts a good choice here? Just looking at this, it's important to kind of start to see these patterns. It's easy to find intercepts. How come? What about the number 40 makes that a pretty good? 8 and 5 are both factors of 40. So it's easy for us to, to set x equal to 0 and solve for y because 5 goes into 40, or set y equal to 0 and solve for x because 8 goes into 40. So intercepts would be a pretty good choice here. So if we let x equal 0, what's y equal to? 8. If we let y equal 0, what's x equal to? Okay, so we get the point 0, 8. So right there. And we get the point 5, 0. And you already told me because this is an equal sign, it's going to be a solid boundary. And then how could I determine which side I shade? Yeah, so I could put it in slope-intercept form. And maybe if that's the way you want to go, then we know that one for free, right? If I put this into slope-intercept form, solving for y, I'd subtract 8x, right? Whoops. negative 8x plus 40, divide by 5, and we would get y is greater than or equal to negative 8/5 x plus 8. Okay, we could have just then graphed that point, used a slope triangle to get the second point. And what does this tell us about how we're gonna, which half plane gets shaded? Yeah, we're gonna go above, aren't we? We want the y values greater than or equal to, so we would shade above, which would give us well, that's not very dark. This would be the shaded half plane. Okay, there is a way I can do this though without having to put it into slope-intercept form. I graphed the boundary line. How could I have easily checked to see which half plane gets shaded? Okay, I could do that. I could just in my mind think, okay, if I put this into slope-intercept form, I can tell that I'm going to get y is greater than or equal to mx plus b. That works, right? One other way I could do it. Yeah, I could just test a point, right? That's the other thing I could do is I could test the point 0, 0, which is right there. If I plug 0 in for x and 0 in for y, I get 0 plus 0. 0 is greater than or equal to 40. True or false? False. Because that's false, I would shade away from that test point. That's not included in the solution set, right? Okay? Plethora of choices here. Take your pick. All right, last one. If I want to write this inequality, what's it going to be? Well, what's the boundary line? X equals 8. Okay, but we're shading a half plane also. So do we want to, how are we going to change that? The boundary line is x equals 8, but we want the values of x that are less than or equal to. Good, because we're including the boundary line. So our answer would be x is less than or equal to 8. Good. All right, I'm done. You can work, get questions answered.